So I would like to start my lightning talk with my fail story, the most successful way to start any talk. So basically, I had my data. I had a few thousand sentences to classify into different categories. Not much of the data, but actually I had a real problem with it. I had a model of my choice. It was hierarchical attention neural network, and it is great that Adi already had a really awesome talk about hierarchical attention neural networks that I don't need to explain the details about it. And also, I have the code that implemented it, and I used TensorFlow. I used TensorFlow 1.14, which was the choice of mine because actually I don't really like TensorFlow 2.0 because of a lot of issues associated with it. So why am I telling about it, and what is the reason I'm describing this problem? Actually, what I got is this issue. So I got the out-of-memory error. This is just the slide to show that I didn't succeed. And just to recap, I had an NVIDIA V100 GPU. This is the best GPU on the market. This is the most expensive one. And this is the best thing that Google Cloud affords us. So I didn't have that much data. I had a pretty complex model, but it should work fine because I had 16 gigabytes of RAM. So what was my issues and why didn't I succeed with even running it at once? I couldn't even run one epoch. I had the batch size 16, which is also not that big. So actually today I'm planning to tell about tips and tricks for hardware acceleration of TensorFlow-based ML service. This talk will be really useful for people who are trying to accelerate their models or who don't have a very good GPU or CPU and who are struggling with acceleration of their systems using either TensorFlow or maybe even PyTorch because the general approach is they are pretty similar. So the first thing I would like to say is that I'm working in OneTouchAnode, which is the cybersecurity company. It is a data privacy solution that provides continuous visibility into your organization's personally identifiable information. We do a lot of stuff from scratch in OneTouch, and we do also a lot of data engineering because we have big data and we need to optimize our models as well as possible. That's why I'm telling about all of this stuff. So actually, to start with, we have TensorFlow, no matter if it is TensorFlow 1.0 or 2.0. We need to install it somehow. So the first idea to install it is actually to use PEEP. The most obvious way, just to do PEEP install TensorFlow, but most likely you will see this issue, which is that your CPU supports instructions that this TensorFlow library was not compiled to use. Most likely, if you have ever installed TensorFlow with PEEP, you have seen this error. This is the thing that shows us that you shouldn't ever use TensorFlow installed with PEEP for your production environment. A lot of people don't know it, and a lot of people are saying that you could simply use PEEP. Why are you struggling with it? But this is not the best way. Actually, even TensorFlow developers are saying that installation with PEEP is only better. You can't do it in production. So here is the list of other instructions and compilers that are also not supported in installation of TensorFlow with PEEP. So some of them are compilers, some of them are instructions. GPU is obviously not supported. So this is the list of technologies that can't be supported with PEEP installation, and there are a lot more. I just mentioned a few of them. So actually, the first thing that comes into mind of the person that read something and tried to do something is the question that, have you tried to compile it with Basil? But this person most likely is very comfortable with C++ because Basil is a build tool. It is actually a compiler that helps you to install TensorFlow using it. So actually, I would like to tell a story how I've been doing it. So first of all, you need to write an installation script. And if you're a data engineer or data scientist, no matter, most likely you are not writing installation script, unless you are DevOps, obviously. So also, you need to read a lot of documentation because all of this installation script, it is pretty specific for the OS system that you are using. For instance, for Ubuntu, it is really different from CentOS, and there is no universal installation script. And also you need to do a lot of test cases, obviously. And you will catch a lot of bugs, because even if you think that you've done everything correctly, most likely, and I have also seen this issue, that if you wrote one installation script, one system that works correctly, maybe on another machine it won't work. I've observed this issue, and this is very, very confusing, and it has a lot of struggles. And also you will need to have some kind of DevOps experience. Why am I saying about all of this stuff in such details? Because actually the people who are able to do that, they are usually not data scientists, not data engineers, not DevOps. So they are somewhere in between all of these fields, and people who can do it from scratch without a lot of efforts, they are really rare for the industry. So this is not the simple thing. So, and then at the end of the day, you will be like this parrot, really stressed, really confused. Like my coworkers say, we're having fun, so-called fun, but this is not fun. So another thing, it is to install it with Docker. This is actually the simplest approach, but not everyone can use it because not all of the applications and like generally systems, not all of them are Dockerized. Because not everyone actually needs microservices and all of the stuff that is associated with microservices. So if you chose to do that, you can simply take the image that you wish to take and to choose the one that has all of the accelerations that you like. For instance, you like Halyna with TensorFlow, okay, you can choose the image of your choice. And the only additional thing that you need to install is the NVIDIA Docker. You need to install it for your system to support the runtime of your Docker image while you are running it. So you have 3 roads. I really don't recommend to take the first road. The second road is for the people who don't use Docker in their production environment. And the third road is the simplest one, and it gives you the most of the control over the process, I would say. So some things about GPU now. Like, when I'm speaking about software acceleration, a lot of people are saying like, okay, you are using GPU, you are already accelerating. So I would like to recap some details about GPU. So actually, running with GPU means to run a lot of small cores in parallel. So actually, it means running a lot of threads that are executing the same computations at one time. In parallel, so it results in a high performance. So just to compare it to CPU, CPU is running a few instructions that are very, very complex, but usually sequentially or with a small number of threads. So just to speak about deep learning, most likely you will need to use CPU for deep learning if you don't have much data. Because GPU is good with all of these small cores, a lot of them, when you have a lot of data and when you can't feed it well into your CPU RAM. And one thing I would like also note that GPU bandwidth is very, very important. By that I mean that you need to have a good speed of copying your data from RAM of CPU to VRAM of GPU. So if this speed is not good, even if your GPU is very, very good and has a great performance, then it even doesn't make sense because the speed of copying it is not good enough and it doesn't result in acceleration at all. So another thing that you need to install for running it with GPU. Obvious set of things that should be installed, but sometimes even doing all of that stuff, if you are running a pretty new machine, it can take a lot of time. Especially installing NVIDIA Docker can take a lot of time on CentOS, in my case. So now a few more things about different TensorFlow frameworks that it has and different ways to speed it up. So a lot of people are also talking about TensorFlow servants, so can we use it for acceleration? Actually we can, but only if you are using TensorFlow 2.0 or higher, because TensorFlow serving operates save model format. And this save model format is only accessible from TensorFlow 0.0 and higher. And the great thing about TensorFlow serving is that it allows us not to write this layer of connection between our model and our API that we are sending the results to. For instance, we are running REST and we have the model, we are doing inference from the model, and we are trying to send the results to the REST server. So this bottleneck when we are sending these results of the model, it can be really speeded up to 30–40% usually. So this is the API of TensorFlow serving, and it can run REST and it can run gRPC. Usually REST is used. Another thing is TensorFlow Light. So TensorFlow Light is the set of instructions that gives the ability to deploy and run models for mobile devices. Also, it is only accessible for TensorFlow 2.0 because of the same reason. It is saved model format. So the greatest thing is that it can be used for on-device inference, but there is another detail that is also useful not only for on-device inference, it is also useful for running it on computers. It is WiDS quantization, like cutting a piece from the cake, which allows you to have the lower precision, but it will give you really great speed up. Sometimes this lowering of precision is 1–2%, but your model is running 2 times faster. So this is about inference on mobile devices. Okay, so another thing I would like to talk about is the speed up using programmatical way, because before I was speaking about installing it using TensorFlow serving, using TensorFlow Light, but what about really the code? Because you can speed up TensorFlow with the code as well. So some general information about TensorFlow. 2 main concepts behind it. I'm talking about 1.14 and other 1-point-something versions, is that there are 2 key concepts. It is graph and it is the session. So graph is the set of operations and weights that we have, and the session is the context executor that helps us to actually evaluate our graph and do some operations with our graph. So session is how we execute, and graph is what we execute, basically. So the biggest bottleneck usually with data science model for doing inference with them is about the data. So how we feed the data really matters for our inferences. So basically there are 3 most common ways, and the first one is we see the TF placeholder approach. This is the simplest and most common approach that the majority of people usually do in research, and this is about feeding the data into the model using simply tensors that are the placeholders. Another thing is that FIFO-Q was introduced during 1.0. And also another thing is the TF data model. It was introduced with TensorFlow 2. So another thing I would like also to mention, but I already don't have time and I won't go into the details, is about RSets, padding, optimizers, and hyperparameter tuning. You should check all of that if you want to make sure that you're running fast. Also, about hyperparameter tuning, the best approach that I know for TensorFlow is the RainTune package. This is the greatest thing, as far as I know, to do that with TensorFlow. Thank you very much for your attention. I hope that your models will work fast, and have a nice rest of the conference.